All right, let's take a look at logarithms and exponents and kind of how they're related to each other. So this part right here we've done for quite a while. We've worked with exponents before. So 10 to the 0, well, anything to the 0 is just 1. We should note that part. 10 to the 1, that's just 10 one time, so that's just 10. 10 squared, well, that's 10 times 10, and 10 times 10 is 100. 10 cubed, well, that's 10 times 10 times 10, which will end up being 1,000. So that part is new. But then we've got logarithms, and they're the inverses. They're the kind of like the opposites. Now, a logarithm, as it's written, is meaningless without a number there. So this is actually a log with a 10. So what you need to know is that when there is no number there, we assume that the number will always be 10. Okay, so we can't just write a 10 in there just for the sake of us remembering that. So this is saying, and this is really interesting, I'll start down here. This question, and you can write it however you want, but this kind of says, maybe I'll do this in green, this says 10 to the what got me 1,000. That's what this says. This is asking 10 to the what gets me 1,000. 10 to what exponent gets me 1,000? Well, the answer is 3. So this is, and I know I wrote it here in the notes, but maybe it's right here. It is simply just 3. 10 cubed got me 1,000. This right here, a logarithm is hard. It's not just a number that you can just think right away. You actually have to ask yourself a little bit of a question, and that question is 10 to the what got me 100. 10 to the what? Well, 10 squared, 10 times 10. So that's a 2. And this, again, this says 10 to the what got me 10. And this says 10 to the what got me 1. So here, 10 to the, looking at this one, 10 to the power of 1 got me 10. And 10 to the power of 0 gets me 1. So that's how you have to kind of read logarithms. Let's try a little bit more. You can see here the question that I just asked, and maybe I'll write it again just so you can see. But this says a to the what gets me x. A to the what gets me x. That's what this says. So I'm trying to, the logarithm is like trying to find out what the exponent is. A to the what exponent gets me x. And whatever my answer is, they called my answer y, then they said, okay, well this must have been the y. So that's kind of how they've written that right here. Some things to note, that x has to always be bigger than or equal to, sorry, bigger than 0. Has to be a positive number, can't be 0. So this number right here has to be positive. And this number here always has to be positive as well. So let's take a look. So right here, we can rewrite this in exponent form, because this question, remember, this says 2 to the what gets me 4. That's what this part says here. Well, the answer, they wrote it right here, 2. So this is written as 2 squared got me 4. So this is 5 squared gets me 25. This is 3 to the negative 2 gets me 1 over 9. And that part might look a little strange, but that's because this is a negative exponent, so you can bring it to the denominator and make it a positive. And then 3 squared is 9. So that might be just a little helpful hint there. So the exponent, our end result here, this right here is the exponent. And so even here, the exponent is your result for a logarithm. So if I have a logarithm, this is 5 and 125. Because it says 5 to the what gets me 125? 3. So the 3 is your kind of your result. So my answer here would have to be the 4. And my answer here has to be the exponent, which is the negative 2. And then it's log base 3 of 81. So 3 to the what gets me 81? Well, 4. And then you can see that 3 to the power of 4. And this is log base 4 of 1 over 16. 4 to the what gets me 1 over 16. And that's negative 2. And you can see that 4 to the negative 2, you would bring that to the denominator, make it a positive 2, and 4 squared is 16. So this is not as important. Like, this is going from log form to exponent form, and some teachers really put an emphasis on this, but I won't going forward. I kind of ask these, I change these kind of in my head, and or reword it in my head a little bit, and you'll see that when I do example number 6 here. Because it says, use a definition to evaluate each logarithm. And I'm not going to write it out, but in my mind, and maybe I'll write this down below, I'm thinking 2 to the what got me 16. That's what I'm asking myself here. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So it must have been a 4. 2 to the power of 4 got me 16. And this question right here in B says 3, because 3 is my base. 3 to the what gets me 27, while 3 squared is 9 and 3 cubed is 27. Okay, so the answer must be 3, because 3 cubed is 27. And this asks 4 to the what gets me 1. And I know this one is because anything to the power of 0 is 1. So this answer here must have been 0. And this asks 3 to the what? Well, I wrote 2. It's not actually true. 3 to the what gets me 1 over 9. Now, whenever you have the 1 overs will be a hint that it will probably be a negative number, because I need to bring it to the denominator. Now 9 is going to be squared. So 3 squared is 9. That's not what I want. So, because I know it's on the denominator, I'll make it a negative there. So then I can bring this the 3 down below and make it a positive 2, which would get me 1 over 9. So the answer must have been negative 2. So that is kind of how you use logarithms. And so it's going to be really important that you know these numbers, that you know how to find it without a calculator. You can actually do this, and now might be a good time to show it. So let me just bring this up here. If you have a logarithm, like this one right here, log 216, if you have a calculator, you might be able to, so for this one, I think if I hit math, there's this thing called log base. And if I select that, you can see the logarithm. And I can put in a 2, and I can put in a 16, and it will spit out a number 4, which is what we got. But the idea is we're not going to have a calculator for all of this. So if you don't have that, there actually is it's called a change of base. But you're allowed to do this. You can do the exact same thing. Here you got log base 2 of 16, but I'm going to do the 16 first. I'm going to do log of 16. I'm not going to choose the base. The base is going to be just a 10. It's not going to be written. Divided by log of 2. So if you don't have the option to put the little subscript 2 in there, you can just do log of the big number divided by log of the little number, and the subscripts are invisible because they're tens. And if you do that, you will also get the correct answer. Logarithms can be anything, like you can do math. So log base 5 of 30. So this is 5 to the power of what gets me 30. Well, I know 5 squared gets me 25, but I don't know. Okay, so it's a random decimal number that kind of goes on, like probably goes on forever. And random. So this says 5 to the power of, I guess, 2.1132 8, 2, 7, 5, 3. That should get me really, really close to 30. So that's how logarithms and exponents are related. So I'll close this, and we're going to do some log laws in the next video.